Hello, in section 2.6 we're going to be looking at combining functions. That means, for example, adding functions together, subtracting functions from each other, multiplying functions together, and dividing functions. Now, when you're doing that kind of thing, it's important to remember that the domain, the possible values of x, have to satisfy f of x and also g of x. If you're adding f of x plus g of x, your x has to work for f of x and also for g of x. It also, if you're dividing f by g, you also have to have the bottom not be equal to 0. So you see in this example here, where f divided by g of x is equal to x squared divided by x plus 3. The bottom part there cannot be equal to -3. X can't be equal to -3. So we have some examples here of using f of x equals 1 over x and g of x equals the square root of x minus 2, this one here. So if you want to get this first one, this f plus g of 3, what we've got to do is very straightforward. We just take f of 3 plus g of 3 and then we add those two things together. So we get effectively 1 over 3. The 1 over 3 comes from 1 over x. And we do the square root of 3 minus 2. That comes from the square root of x minus 2. We're just plugging 3 into both of those functions. When we add those together, we'll get 1 and 1/3. That's all. With f minus g of 2, we're just subtracting those two things. So it's just a case of putting 2 in place of the x, in both cases there, and subtracting those two things. If we do that, what we should get is f of 2 minus g of 2, which is equal to 1/2 plus the square root of 2 minus 2. Again, that's just substituting 2 in place of the x. And if you calculate that, that should give you 1/2. For fg of x, f times g of x, we're going to have to multiply this times this and plug in a value of 6 for x. So if we do that, what we should get to start off with is just f of 6 times g of 6. When you calculate f of 6, it's going to be 1 over 6. And when you calculate g of 6, that's going to be the square root of 6 minus 2. So if you do that, what you should end up with is 1/6 times the square root of 6 minus 2. And if you do that calculation, what you'll end up with after that should be 1/3. In these next ones, we have f divided by g of 3. So again, we'll just plug 3 into f, we'll plug 3 into this, and then divide those two things. So in this case, we'll get f of 3 divided by g of 3. That's 1/3 over square root of 3 minus 2. Just plugging 3 into f and into g. And then after that, it's just a case of simplifying that. We'll get 1/3 divided by 1. And anything divided by 1 should just be that thing itself, 1/3. And finally, in part E, it's a little bit different, and we'll see how different in a second. The g divided by f, we're going to do this thing here, the g of x divided by the f. We're going to leave the x in there in this case. So we're not going to plug in a value for x, we're just going to leave the x there. So we're going to get the square root of x minus 2 over 1 over x. Now that sounds a bit strange, but if we try it, we'll get g of x over f of x, followed by square root of x minus 2 over 1 over x. It's possible to simplify that. If you're dividing by 1 over x, that's the same as multiplying by x. And when you end up with that, notice that your domain, you can't have, on the top you can't have x be a value that gives you the square root being negative. So x has to be 2 or more. And you can't, this 1 over x, you can't put x equals 0 into that. So we've got x not equal to 0 here. Even though in this final simplified version here, there isn't a problem with x being equal to 0. It's the constituent parts you have to look at, the f and the g, and make sure those things, that the x values can go into the f of x and that the x values can go into the g of x. So it's not the simplified version you look at for the domain, it's the individual functions.